There is a genome hiding inside a modern nation that should not exist in its current form. Population geneticists who study Western Asia have a term for it, half admiration and half disbelief. A living fossil. Not because the people are unchanged. Because their ancestry stopped mixing in any significant way, roughly 3,000 years ago, and then simply held. For a region defined by conquest after conquest, empire after empire, that kind of genetic stillness should not be possible. And yet the DNA insists it happened. Which means somewhere in that stillness is a story historians only partly understood, hiding beneath names that end in the same quiet syllable, generation after generation, for centuries. For most of the last 2,000 years, the story of Armenian origin seemed settled enough to teach in a single lesson. An ancient highland people, descended from populations who once lived in and around the kingdom of Urartu, later absorbed into an Armenian identity shaped by the Artaxiad and Ars-Acid dynasties, converting to Christianity as a state religion in the early 4th century, then enduring empire after empire, Persian, Roman, Byzantine, Arab, Mongol, Ottoman, Russian, while somehow preserving a distinct language, a distinct alphabet, and a distinct sense of peoplehood. Linguists placed Armenian in its own singular branch of the Indo-European family tree, related to nothing else closely enough to call it a sibling. Historians described a highland civilization that survived by adapting, migrating, and rebuilding again and again across a landscape that connected and threatened Europe, the Caucasus, and the Near East all at once. The surnames Armenian families carry today, most ending in the patronymic suffix, ian, or yen, meaning son of or descendant of, seemed to fit neatly into that story. A people who had been pushed, scattered, and forced into diaspora again and again, still naming their children in a way that pointed backward, generation after generation, toward a single point of origin on the same ancient highland. It was a coherent story. It explained the resilience. It explained the language. It explained the names. It did not explain what happened when researchers finally sequenced the genome behind it. The first crack did not come from history. It came from a pattern that simply refused to behave the way surrounding populations behaved. Across much of West Asia, thousands of years of empire, trade, and conquest left a signature in the DNA, a slow, steady blending between neighboring groups, visible in autosomal data as populations gradually converge toward one another over centuries of contact. Anatolia shows it. The Levant shows it. Mesopotamia shows it. Armenia, according to the genetic data, does not. Researchers comparing modern Armenian genomes to populations across the wider region kept encountering something unusual, a population that looked like it should have mixed extensively with its neighbors, given the historical record of empires passing directly through its territory, and yet showed a level of genetic isolation more typical of populations separated by oceans, not open highland corridors. It was the kind of anomaly that does not resolve itself. It deepens the longer you look at it. That anomaly is what pulled genetics fully into the story. Modern population genetics works by comparing several layers of the human genome at once. Mitochondrial DNA, inherited only through the maternal line, offers a record of ancestral mothers stretching back tens of thousands of years. The Y chromosome, passed almost unchanged from father to son, preserves a parallel record along the paternal line, a record that matters enormously for a naming system built entirely around patrilineal descent. And autosomal DNA, inherited from both parents and reshuffled every generation, offers the clearest picture of overall ancestry proportions, revealing which ancient populations contributed to a group and roughly when those contributions occurred. Ancient DNA, extracted directly from skeletal remains rather than reconstructed backward from living people, adds something no modern sample can. A genetic snapshot frozen at a specific point in the past, unaffected by anything that happened afterward. When researchers applied these tools to the Armenian highland, the old, simple story did not collapse. It widened. What they found was not a population that had remained untouched since deep prehistory, as some earlier romantic narratives assumed. Instead, the genome revealed a population that had formed through a real, substantial mixing event, multiple distinct ancestral populations blending together on the highlands sometime during the Bronze Age, likely between roughly 3,000 and 5,000 years ago. Groups with genetic affinities toward the wider Caucasus, toward populations further south in the Fertile Crescent, and toward populations connected to the broader movements reshaping West Asia during that period, all appear to have converged in the same highland region. That was not a contradiction of the ancient kingdom story. It was something stranger, confirmation that the single ancient people story was, in a sense, correct, but only from a specific point onward. Before that point, there was no single Armenian genetic lineage waiting quietly in place for thousands of years. There was convergence, a blending, a formation event. And then, almost as soon as that formation completed, something remarkable happened. The mixing largely stopped. If you find the idea of a population effectively sealing its own genetic record almost 3,000 years ago as strange as I do, you may want to subscribe, because these kinds of frozen-in-time signals are rarer and more revealing than most people realize. At least 3 explanations have been proposed for why that isolation set in, and researchers remain genuinely divided on which combination is closest to the truth. The first is geographic. The Armenian highland is a landscape of elevated plateaus and mountain barriers, and populations in comparably rugged terrain elsewhere in the world. The Caucasus, parts of the Himalayas, isolated highland regions in Africa, show similarly reduced rates of genetic mixing with lowland neighbors, simply because sustained large-scale intermarriage across difficult terrain was historically harder to maintain. The second is social and religious. After the adoption of Christianity as a state religion in the early 4th century, in a region increasingly surrounded by different religious and political structures, endogamy, marriage largely within the existing community, may have functioned as a form of cultural preservation, reinforced over centuries by identity, faith, and shared language, even while political rule above the population changed hands repeatedly. The third is more structural and harder to prove directly. A founder effect following a population bottleneck in which a smaller effective breeding population, having already formed through that earlier Bronze Age blending, simply propagated its existing genetic diversity forward through many subsequent generations, without large new ancestral streams being added, regardless of which empire held nominal control above them. None of these explanations cancel each other out. It is entirely possible that geography made isolation easier, that social structure reinforced it, and that a founder effect amplified its genetic visibility over time. Untangling exactly how much each contributed became the task of the most significant study in this field. That study came from genome-wide analysis combining large modern Armenian sample sets with ancient DNA recovered from Bronze Age burial sites across the highland and surrounding region, among the more comprehensive comparisons of its kind for this part of West Asia. Rather than relying only on modern genomes compared statistically backward through time, researchers could now compare living Armenians directly against the DNA of people who had lived in the same landscape 3,000 years earlier. The result was the clearest confirmation yet of the formation then isolation pattern. The ancient Bronze Age samples showed the expected signature of mixture between distinct ancestral groups. The modern samples showed remarkable continuity with those same ancient genomes, a level of continuity researchers described as unusual for a population situated at a historical crossroads this heavily traveled by later empires. Whatever demographic changes those empires brought, at the level of the broad genetic pool, they largely moved around the population more than they moved into it. That was the landmark finding. But it was not, in the end, the twist. The twist came from a smaller, quieter detail buried inside the same data. A detail that did not concern the highlands' isolation, but its formation. When researchers modeled exactly which ancient populations had converged to create the Bronze Age Armenian genetic profile in the first place, one of the contributing ancestral streams did not point toward the immediate neighboring regions historians expected. It pointed further out, toward ancestry connected to populations associated with much earlier expansions across the wider steppe and West Asian corridor. A signal more commonly associated with populations far to the northeast, models that predated any account in the historical record. Not a contradiction of the highland origin story. Something older sitting beneath it. Not the neighbors immediately surrounding ancient Armenia, but a deeper ancestral current connected to population movements far outside the boundaries anyone had assumed defined this highland's genetic history. The genome was not erasing the ancient kingdom. It was revealing a layer that existed before there was a kingdom to found at all. What this means extends well past one highland. Population. It means that a people who spent the intervening millennia scattered by empire, converted, ruled, sometimes forced into diaspora and sometimes forced to return, were not simply the unbroken continuation of a static ancient identity. They were the product of an ancient convergence, several ancestral streams meeting on a mountainous crossroads deep in the Bronze Age, followed by an unusually long, unusually stable period in which that convergence held together almost undisturbed, even while the political map above it changed hands more times than most nations experience in their entire recorded history. It means the surname a family carries today, tracing patrilineal descent back through named fathers for generation after generation, is doing something genuinely rare among human populations. It is naming a line that, at the genetic level, largely does trace back toward that same deep highland convergence, not because the family record proves every individual link, but because the population itself preserved that continuity at a scale most groups facing comparable historical pressure did not. Picture the highland itself for a moment. Not a single mountain, but a folded landscape of high plateaus, volcanic peaks, and river valleys cut between them, where snowmelt feeds terraced fields that have been worked in roughly the same places for thousands of years. Winters close the high passes for months at a time, turning neighboring valleys into worlds that see little of each other until spring. Ancient monasteries sit built into cliff faces that overlook gorges old enough to have watched Urartian fortresses rise and fall long before the first Armenian kingdom was named. It is not a landscape built for constant movement. It is a landscape built for holding on. That, in the end, may be the deepest thing the genome has confirmed. Not a myth of untouched purity, because the ancient mixing event makes that impossible to claim honestly. Not a simple, unbroken line from a single founding ancestor, because the deeper ancestral signal complicates that too. What the DNA offers instead is something more human than either extreme. A record of a people who formed, once, through convergence on a defensible highland, and then held that formation together with a persistence unusual enough that geneticists working thousands of miles away, comparing datasets with no interest in mythology at all, kept finding a signal too coherent to ignore. The old story was not wrong. It was simply too small to hold everything the genome eventually revealed. The kingdom did not create the people. Something older created the people, and the kingdom was simply the first chapter written down. If a story like this changes how you think about the name your own family carries, that reaction is worth sitting with. Subscribe if you want more of these investigations, where the evidence quietly rewrites a map we assumed had already been finished. The highland is still there, still folded, still holding its passes closed through winter the way it has for thousands of years. And somewhere inside the DNA of the people who trace their names back to it, an older meeting than any empire is still, quietly, being remembered.